Welcome, celestial explorers, to a captivating voyage through the annals of time and space. Today, we embark on an extraordinary journey to unravel the mysteries of the solar system's genesis. How did our cosmic neighborhood come into being? What forces shaped the planets, moons, and asteroids that we know today? Prepare to be awed as we delve into the scientific narrative of solar system formation, a tale of swirling nebulae, stellar nurseries, and the birth of worlds. Our story begins some 4.6 billion years ago, in a vast molecular cloud known as the solar nebula. This cloud, a sprawling mix of gas and dust, was the primordial seedbed for the solar system. Under the influence of gravity, the nebula began to collapse, spinning faster and flattening into a rotating disk. At the center, the concentration of mass grew denser, laying the foundation for our sun. As the proto-sun ignited, its fiery breath swept through the disk, clearing away gases and leaving behind a menagerie of solid particles. These ranged from tiny grains of dust to larger bodies known as planetesimals. Through a process called accretion, these bodies collided and stuck together, gradually growing into the planets we know today. The inner region of the disk, warmer and closer to the sun, gave birth to the rocky terrestrial planets, Mercury, Venus, Earth, and Mars. Further out, where it was cooler, gas giants like Jupiter and Saturn formed, their massive gravity wells capturing swirling clouds of gas and icy materials. Beyond the gas giants, the icy worlds of Uranus and Neptune emerged, completing the family of planets. The formation of the solar system was not a peaceful process. The early solar system was a chaotic arena of colliding bodies, a cosmic pinball machine that shaped the orbits and surfaces of planets. Evidence of this tumultuous past can still be seen in the craters on the Moon and the asteroid belt, a relic of a planet that never quite formed between Mars and Jupiter. Within the swirling disk of the solar nebula, the distribution of materials played a crucial role in the formation of the different types of planets. The terrestrial planets, with their solid surfaces and metallic cores, are rich in silicate rocks and metals that could withstand the high temperatures near the sun. In contrast, the gas giants, Jupiter and Saturn, amassed vast atmospheres of hydrogen and helium, with Jupiter's massive size allowing it to capture even more gases and form a diverse set of moons. The ice giants, Uranus and Neptune, are composed of water, ammonia, and methane ices, along with hydrogen and helium. Their formation further out in the cooler regions of the disk allowed these volatile materials to solidify and contribute to the bulk of their composition. The unique environments of these planets and their moons have become focal points for the study of potential habitats for life beyond Earth. The Kuiper Belt and the Oort cloud, two regions beyond Neptune, are the reservoirs of icy bodies left over from the formation of the solar system. These regions are thought to be the birthplaces of short-period and long-period comets, respectively, which occasionally visit the inner solar system, providing clues about the conditions during the early stages of planetary formation. As we conclude our cosmic journey, we are left with a profound sense of wonder. The formation of the solar system is a testament to the intricate dance of gravitational forces, the relentless drive of accretion, and the serendipity of celestial collisions. From a formless cloud of gas and dust, our solar system emerged, a diverse and dynamic ensemble of planets, moons, and myriad smaller bodies. The story of solar system formation is not just a tale of the past. It is a key to understanding our place in the universe. It reminds us that we are the children of stars, heirs to a legacy of cosmic evolution. As we gaze up at the night sky, we are reminded of our origins, a reminder that inspires us to continue exploring the cosmos, seeking the secrets that lie beyond our celestial home. The formation of the solar system is a saga of cosmic evolution that continues to unfold as we uncover new insights into the processes that shaped our celestial neighborhood. From the intricate dynamics of planetary orbits to the diverse compositions of worlds, each discovery adds a brushstroke to the grand canvas of our understanding. As we reflect on the journey from a nebulous cloud to a bustling system of planets, we are reminded of the fundamental forces that govern the universe. Forces that may also be at play in the birth of other solar systems around distant stars. The story of our cosmic origins is a beacon of inspiration, guiding us as we venture forth into the unknown, seeking to unravel the endless mysteries of the cosmos. Thank you for joining us on this extraordinary voyage through time and space. The formation of the solar system is a narrative woven into the very fabric of our existence. As we continue to probe the mysteries of the universe, let us carry with us the awe and curiosity that this story inspires. Until next time, keep looking up and wondering at the celestial ballet that brought us into being. Thank you for watching. If you're hungry for more knowledge, hit that like button and don't forget to subscribe. Your support is incredibly valuable to us.